Okay. So what we're going to do today is basically look at how you fill out truth tables and what the significance of the results are. There are some problems earlier in the section as far as the homework assignment where you don't necessarily have to use the full truth tables. I'm going to do the truth tables, then I'm going to look at a specific question about one row and explain how you can do that without using the truth table. It's easier to do that, I think, than try to explain how to do it without the truth table, because the truth tables are, to me, very, there's a certain pattern that's easy to generate or process to come up with. So, for example, this is some of the homework problems say, let P be a false statement and let Q be a true statement, and then you're supposed to find the truth value of a compound statement. So rather than doing that, we're going to look at the compound statement, fill out the truth table, and then answer the question, and then look at it from how you would answer it without using the truth table. So that's, hopefully I wasn't repeating myself too much there. So let me add a page, and this is the compound statement that we're going to look at. So we're going to go through the process, which I outlined, I think, the other day, and we'll write down the steps. So the first step in filling out a truth table is to determine the number of rows and columns in the truth table. So the number of rows is determined by the number of statements that are in the compound statement. So it's pretty much looking at the compound statement here and seeing how many different letters we have. So we call n the number of statements. N is equal to 3 because we have P and we have Q and we have R. Now we have the negation of R, but that doesn't matter. That's just changing the truth value, but those are the three statements, whatever those letters represent. So we're not worried about what those represent right now. We're just showing you what the mechanism is for filling out the truth table. So with that, once you have the number of statements, which is pretty easy, you use the formula 2 to the n to give you the number of rows. So this is for rows. Let's write that down. So you take 2 to the third power, which is 2 times 2 times 2, which is 8. So, and then we add one row for the header. So that just describes what each column represents. So the total number of rows is equal to 8, the ones we need to fill out all the truth values, plus 1, which is the header. It's always plus 1. So we need 9 rows in our table. Okay, the other dimension of the table is how many columns. Pardon me? N stands for the number of letters, which represent the number of statements. The number of columns, you use N again. So N is still 3. And that's we need those 3 columns because we need to list all the possible combinations of trues and falses for 3 statements in this case. So that's the first thing we need, plus whatever n is. You've done that in the previous step, plus enough columns to write the compound logic statement. The compound logic statement is the thing that's in red. And the way I do that is, the first thing you do is you look for cases of just the letters by themselves. So we have Q, Now, if you have a negation, we count that as one. We don't have to have two. We don't have to have two rows, and I mean two columns. And we have P. So we need 3 just to represent Q, the negation of R, and P. And then we need columns to show the result of doing the AND, in this case, and the OR and the AND operator. So you see I've got 5 circles. So we need enough columns to write the compound logic statement, which in this case is 5 from above. 1, 2, 3, 4, 5. So that for a total of 8 columns. Now in the test, I'm going to give you, what I do is I give you a table that has more columns and more rows than you need, and you just black out, you just cross out the ones you don't need. So you don't actually have to create your own table, because it's a lot easier to use in my stuff. Okay, so that's step 1. Step number 2 is to draw your table, which you won't have to do. You'll have to do it for your homework. So I'm going to draw my table. And so I have 8 columns. And you'll say, well, you only have 5 rows, and that's because the software won't allow me to do more than 8 rows, so I have to create it that way. So you see my table has 8 columns and 9 rows. Okay, step number 3, fill in header row. The header row is the top. So the first thing you do is you just write the letters that are involved in the original, in the compound statement. And we don't put the negation, we just put P, Q, and R. We usually do it in alphabetical order. So P, Q, R. What we'll use these columns for is to come up with a pattern that makes sure that we cover all possible combinations of trues and falses. So that's why we have n equals 3, 1, 2, 3. Then we have to write out our compound statement. So we have the statement is Q or not R and P. You see, if I've included the parentheses in there because that's the original statement that has the parentheses, but those are just used for grouping things together. So negations, you don't need a separate column. Parentheses, you don't need a separate column. There's actually 2 ways of filling out these tables. I find this way to make more sense. There are a few people who read the book and they see the other way and they like that way, but I'm going to do it this way. It typically requires more columns, but I think it makes more sense. Okay, so fill in the header row. That's step 3. Step 4 is fill out the first n columns to cover all combinations of T and F. Now, if you take the second semester, instead of taking statistics, we'll talk about why you need 8 rows to cover all the possible combinations. But for right now, you just know that that's the case. By the way, this is just to let you know about statistics versus second semester, because you're going to be doing your scheduling soon. So most social science programs, like social work, require you to have a statistics class at some point. And so if you're just trying to get an associate degree, the second semester of math or liberal arts is probably easier than statistics. It's from an easy standpoint. But for transferring to a 4-year school and having a math credit that you know is going to transfer and count towards your degree, statistics is probably the choice to make. If you are, but it is more difficult. Mr. Appel teaches the class, and you know, typically the people who go into statistics are the better students in math or the liberal arts, or the ones that really know that they need to take statistics for their major. Anyway, if you want any more information on that choice, because if you take math and liberal arts too, and then you go to a college and they're going to have to take statistics, that's not going to be that great. So it turns out that the community college system is looking at changing the math requirement so that everybody takes one semester of what they're going to call quantitative reasoning, which is some of the stuff we cover in math for the liberal arts, but a little bit more specific. And then everybody who's transferring to a four-year school would take statistics the second semester. We'd have to reduce for associate degree only. We might reduce the math to just one semester, but that's not next year. It's probably the year after next. But anyway, just so you know. So to fill out these first three columns in this case, we did two columns before. Let's go back to that and explain how we filled this out the other day. So we only had two statements, P and Q. And what we did is we said, okay, the pattern is you do two trues and two falses, and then you alternate true, false, true, false. So we have one additional column. So instead of just doing two trues and two falses, because we have now eight rows, we do four trues and four falses for the first row. And then we do two trues and two falses. But of course, if we only do them once each, we don't have enough. We've got to keep filling them in until we run out of room. So these are 4 in a row, 4 in a row, 2 in a row, 2 in a row, 2 in a row. And then finally, for the last statement, we alternate. And by doing that pattern, we come up with 8 different patterns. Here, 1, 2, 3, 4, 5, 6, 7, 8. And these are all the possible combinations. True for the first statement, true for the second statement, true for the third statement, and so on all the way down to false for all of them. So when you fill out these tables, the first 2 or 3 rows, we'll never put 4 columns on the test. They're all the same. So it would be, if you don't quite get this, the pattern stuff, just write it on your cheat sheet and copy it down, because that's all it is. There's no thought process to this at all. It's just a pattern that covers all the combinations. Okay, so that's the fourth step. Fill in those rows, and then the next thing you would do is you would copy P, Q, R into the logic statement, which is what we still have left. That's the right part, and fill in not P, not Q, and not R also. So let's do that. So you can see we've got Q, we've got P. So all we do is we just copy down the truth values that are already shown on the left-hand side. So this is the Q column, this is the Q column. So we just copy them down. True, true, false, false. I'm just, I can go over there and look at them and copy them down. So it's just a matter of copying stuff. And then the other one we have in the logic statement is P. So we look at the P column and we see that we have 4 trues and we have 4 falses. So we just copy that down. They are going to include this stuff in the quantitative reasoning, set theory and logic. Okay, then the negation stuff. Well, the negation operation says that if you have a true for the original statement, the true in the negation becomes the opposite truth value. So trues become falses and false becomes trues. So looking at our R column, all the trues going over to the same row become falses, and the falses become trues. So because of that, instead of going true, false, true, false, true, false, true, false, it's going to be the opposite, which is false, true. Oh, got in the wrong column. So it's in this column. So it's going to be false, true, false, true, false, true, false, true, which is opposite of what we have here. So that's step 6. And then last step is to perform the logic operators. The logic operators are the and the or statements. So you see we have an or statement and we have an and statement. So which one of these two should I do first? The and, the or the and? How many people think I should do the or first? That's the one that looks like this. Okay, how many people think I should do the and first? So a lot of people didn't know what to do either way. So the answer is we do this one because it's inside the parentheses. So we use the parentheses to tell us which operation to do first. If we didn't have it, we'd just go from left to right. It wouldn't actually make any difference. So this column represents the result from comparing these two values, the true and the false, using the or truth table. So the or truth, let me just write these down. So the or truth table looks something like this. So we have first column is P, the second column is Q, the final column is P or Q. And the first two columns are just the normal pattern: true, true, false, false, true, false, true, false. And the result is an or is true if any of the two, the first and the second, the first or the second, is true. The only time an or statement is false is when they're both false. So the truth table for the or operator is true, 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 false. So we can use this truth table for this or operation to answer the question of what do I put in these columns. So, and I'm comparing what's on either side. That's why I like to do this, because it's in the order that I want it. We're going to be comparing this column versus that column. And this value represents what's here, and this represents what's there. And the result, which is here, goes in the middle. So it's a slightly different order. It's kind of like that's in the middle. So if the first one, and we don't really care, we don't look at what's up here. All we do is we compare the truth values with what we have in the truth table. So all we're doing is saying if T is in the first part and false is in the second part, which is this row, the answer is true. So we put a true there. We could do the same thing, next one. We have a true and a true, which true and true gives us a true. And we could keep doing that, but the easiest way to do it is the fact that because we only have one case where it's false, it's easier to just do the false ones, fill those out first, and then make everything else true. So that's what I'm going to do from now on. So I compare these two columns, and I look for the case where they're both false. That's both false, so that's false. And I go through and I say, oh, there's another one, they're both false. I don't see any others that are both false, so that makes everything else has to be true. So that's the quick way of doing it instead of having to keep looking over here and going back. But you can see everything that I've done here agrees with the table. Then what you do is this is the result of the log. The last thing we do in the table is the result of the entire compound statement. Now, so in this case, we compare this column, because we haven't done anything with that yet, with this column. Because what we're doing is we're taking the result of this operation inside the parentheses, and we're comparing the result of this to the result of just P by itself. So what I'm going to do now is I'm going to use an arrow to show the last step and I was going to use green, so I don't know why red came up there. I guess I pushed the wrong button. So what we're going to do, the last step, is we're going to compare these two columns. And the operation is the AND operation. So what I'm going to do is I'm going to go over here and erase this. I'm going to put P and Q. And the truth table for that particular operation is true, false, 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 compared to true, 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 false. The only time an AND is true, when you compare two statements, the only time the compound statement is true when it's connected by an AND is when both the first statement and the second statement are true. Pardon me? Where I'm pointing to OR because this is just the truth table to be used for this AND operation. So I'm not going to use this. Just P and Q here are not really the P and Q in this particular example. What they are just, I could give them some other name. Maybe that's confusing because I'm using the same letters. But this is just the truth table. I could do it something like this. I could maybe to make it less confusing. Maybe it makes it less confusing. You know, I could say statement 1, statement 2, and then the result of using statement 2, and the result of statement 1 and statement 2 using the AND. So this would be statement 1, and this would be statement 2. And then I'm comparing these two, this and that, to give me the result. And I'm going to use green. So again, I could go to this truth table and just look for true, true, and come down here and true, true, and the result is true. But an AND statement is only true if both the first and the second statement are true. So really the quick way of doing it would be to compare these two columns and look for the cases where you have true in both places. That's easy comparison. So I look here and I see, okay, they're both true, so I'm going to put true as the answer. Do I see another place where they're true twice? Yeah, right here. True, true, so that's true. That one's not the same. Here's one where it's true in both cases. And I look down and I see none of the others have trues, both here and here and here. So that means since I've covered all the ones that are kind of the exception, all the rest of them I can just fill in without thinking too hard about it. I don't even have to look at them. I have to just find the two true cases and put the trues there, and everything else is false. So that's the answer right there. So we'll find out later, you just have to trust me here, that when this column has certain characteristics, you can say whether an argument or a logic argument is valid or not based on what the result is in this column. That's the basic concept. The other thing that you can use this column for is if you want to compare two statements and you want to see whether they're equivalent or not. When we talked about computers the other day, we said a lot of times it's easier to make one kind of circuit than another kind of circuit. So if you're designing a logic circuit and you want to find something that an equivalent circuit that gives you the same results, then you would compare the truth tables for those two circuits, and if they're the same, then you can use the two circuits interchangeably and they would function the same. Now let's go back and look at this question here. So if they say let P represent a true statement and Q and R represent false statements, find the truth value of the given compound statement. Well, this is the same statement we just looked at. So let's look in our table and see if we can find out what they're talking about. They're saying let P represent a true statement and Q and R represent false statements. So we go to our table and we look at these first three columns. Do we see one of the rows where the first entry is true for P and the second and third entries are false for Q and R? Yeah, it's the fourth one down, right? It's this row right here. And so from my table, I know the answer is true. Okay. So we can answer that question by looking at the truth table and picking the row that applies to that particular case. Now, if I didn't do that, how the heck do I answer the question? Now, the reason I will not ask you to do this on the test. I will ask you to do this in the test, so make sure you know how to fill out a truth table. So I'm going to try to explain how it works. So it says, we're going to say that statement P, we're going to use an arrow just to say it's not equal to true, but it represents a true statement. Statement Q is a false statement, and R is a false statement. So that's kind of like me filling out the first three columns. This is for a specific case, not for all cases, but for a specific case. Now, if I look at my logic expression here, I also need what is the truth value of the negation of R. Well, the truth value for R was false, therefore the truth value for the negation of R is true. If I had the negation of Q, I'd write that down and I'd change the truth value associated with it. Okay, now, if I look at this logic expression, I'm going to do the first part, this part in the parentheses first. So I say, what is the truth value for this part of the logic expression? Well, what you do is you can plug in, rather than the letters, you can put in the truth values. So Q is false. So I put Q for false. I have the OR statement, and I have the negation of R, which is true. So the result for that, so what that says is if the first statement is false and the second statement is true, and you use the word OR, the OR statement is true if either the first and the second, the first but not the second, or the second but not the first, are true. The only time the OR statement is false is if they're both false. So the result of that particular operation here is true, using the truth table for the OR statement. Then what I can do is for this, I can substitute in the truth value that I just calculated. So I'm going to, let me write the statement out, because that's, so now I have my original the entire original statement. So for this, the truth value for this part I just did previously was true. And then I have the AND connector with P. P has a truth value of true. And the result of that operation is true, because for the AND statement, both the first and the second parts of the statement have to be true for the result to be true. So that becomes true, and that's your answer, which is what I just read off the table a second ago. So it's kind of, they're shorter questions. It's a little more, you have to think a little bit harder to be able to answer the questions. So that's what they're looking for when they ask you these questions in the homework. And skip over that stuff. Okay. So we're just going to keep practicing here. I'm actually reverting back to an easier problem. So maybe, let's see if you guys can, if you look at the steps, so you can help me fill this thing out now. So I'll ask you questions. What was step 1 from your notes? Okay. So the number of, what do we do first, rows? So how many, I'm not going to tell you how to do it, but I'm going to give you a choice and you're going to vote on it. So those are the choices. So look at your notes, see if you can figure out what to do. Figure out what n is. Then you take 2 to the n power. And then we do what with that? What's the next thing after that? Add 1. So how many people think we need to have 4 columns, 4 rows? How many people say 5 rows? How many people say 6 rows? How many people say 7 rows? Okay, so you were correct. So it's 5 rows because we have P and Q, which is, so n is equal to 2 because we have P and Q. We raise that to the second power. That's equal to 4. And then we take 4 plus 1 for the header row. That's 5 rows. Okay, so we need 5 rows. Columns. So we have the same choices here. So what you do first is you take n, which is 2, and then you figure out how many columns you need to write the logic statement. So you can put circles around the parts that you think you need a column for. Okay, so now we're voting. So how many people think you need 4 columns, 5 columns, 6 columns, 7 columns? Nobody's voting. 5, you're going to vote for 5? Anybody else vote for 5? Now that Jackson's decided, huh? 5, yeah. So you've got n is equal to 2, and you've got 1, 2, 3. Okay, so we got 5. So you've got 5 columns. So that's step 1. Draw your table. So we need a 5 by 5 table, which I can do pretty quickly here. Okay, step number 3 was fill in the header row, right? So what do I put here? P, Q. Okay. And then we write the logic statement in there like that. So that's filling out the header row. Then we fill out the P and Q so that we cover all the possible combinations. You can go back and look at your notes, or you can just try to remember what the pattern is. So I'm going to ask Hayden, there's 4 values here, so tell me in the right order. What's the first one? True or false? Right here. True. True. False. False. Good. Harmony. So what's Q? Yep, exactly. Okay. And then so that was the next step. Fill in those columns. If it was 3 variables or 3 statements, we do true, 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 false, 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 true, true, false, false, true, true, false, 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 and then true, false, true, false, true, false. So who am I going to ask now? Harley. So if P has true, true, false, false, what does the negation of P have? Yes. Mm-hmm. What does this negation do? What does that mean? If you have a true, it becomes, and the false becomes true. So if this is true, true, false, false, this should be false, false, true, true. Okay. Who am I going to ask now? So I'm good at picking out names when I see it on the list. Miranda? That's not Miranda. Okay, what is it here? That's Miranda. I was thinking of somebody else. Okay, hold on just a second. Here, we'll oh, yeah, Laramie. Sorry. Okay, so Laramie. How should I fill out the negation of Q? Yeah, false, true, false, true. And what is the operator that's in the remaining column, Justin? The little v. Does that mean or does it mean an and? You've got a 50% chance. Got 2 seconds to give me your guess. Yeah, just yeah. So or, right. Okay, so that's the or statement, and I'll keep with you. So the or statement is false only when, what's that somebody was saying? Oh, Harley said, when they are both false. So which row are they both false? First one. So this is false, and all the rest are true. And there's your answer. We're done. Okay, here's your assignment for making sure you watch this video. So the question for today is Sir Isaac Newton. So Sir Isaac Newton was one of the pillars in mathematics. And what I want you to find out, go to Wikipedia, and what college or university was he a professor at? And send me that information. Okay, so let's do another one. This one's more complicated. Is that the same? That was kind of, well, no, it's not the same. What do we do? We did Q, not, yeah, okay, so we got a different arrangement, similar to it, but, okay, so there's our next logic statement. So we're going to go through the same questions. Number of rows. So the possible choices I'm going to give you here are so I'll give you a few seconds to figure out. Okay, here's the vote coming up. Oh, how did you get 10? So that's, yep. Okay, so you take 2 to its third power, which is 2 times 2 times 2, which is 8, plus 1 is 9. That's okay. So the answer is 9 rows. Okay, so what we did, we took 2 cubed plus 1, which is 9. Okay, number of columns. So in this case, n was 3. We didn't write it down, but n is 3. So we need three columns for those, plus how many spaces do we need for the logic expression? So I will ask Miranda this time. How many columns do I need to write the logic expression? Okay, so, well, let me see if I have Mary Jo. 5. How about, does everybody agree with that? 5? Look good? How did you figure that out? So you need 1 for this, and you need 1 for that. That's 2. And you need 1 for each. You need 1 for that and 1 for that. So there's 5. 1, 2, 3, 4, 5. So the answer is 8. So Okay, so it's the same size as we had in our previous problem, just because they're very, if you look at the two problems, you'll see that they look almost the same. Difference is this is a negation of Q, and we do this operation first. So I'm going to make my table up. So it's 8 by 5, and then I'll clone it. Did anybody watch the debate on Monday night? Yeah. So, what's that? You bits of it? Yeah. Yeah, I did watch the whole thing. So what did you think? What's that? Yeah. Have you paid much attention to the candidates? Yeah. Yeah, it's oh yeah, and if the other interesting thing is the post debate discussions. Anyway, but it'll be interesting to see what happens next time. If Trump gets nastier. He was actually more reserved than I thought he would be. Because the interesting thing is supporters basically want him to get mean because they hate Hillary. Well, not quite as bad as that, but yeah, yeah. Well, yeah, yeah. Hitler had his bad mustache, but so yeah, they're angry. Yeah, they are angry. They hate Hillary. The problem is, what's the problem with that? Doing what the supporters of Trump.
I think his strategy was pretty brilliant because he's gotten tons of free publicity. I can't knock it too much because it's working.
Yeah, it is working, and that's scary. But that's.
He does realize that. Like I think it is actually a measure. Like this years ago back in the 80s I watched, and he said maybe like he said it was okay if people seen her off the side of him than what was really him.
Right. Right. Yeah. Yeah, it's interesting. It is for great publicity, but at some point, if he gets nasty next time, what he needs is his non-hardcore supporters to vote for him, because I don't think just his hardcore supporters alone aren't enough. So if he does something to make his supporters happy by being nasty to Hillary, he's going to alienate the people he needs to get voted in. So he's going to self-destruct. So I would encourage, if I was Hillary's, I'd say, like, yeah, go on, go for the stories about, questioning Bill's, I don't know if you have to question because we know he did it, but his marital infidelities. Yeah, I mean, a key part of the block, some of the key people that are going to determine this election are young people, and secondly is women. And so if he starts, well, it depends on whether it's college educated or, yeah, college educated women. It's the first time that they have voted more Democratic. It's amazing. There's so many blocks of voters that don't like him at all. I don't know where the white angry male and their wives must be. Yeah. Yeah. Anyway, so back to off of politics. Okay. Yep.
So the top picture was a picture of Hillary, and she was like pointing at Trump.
Yeah.
And the caption said, "Show us your tax returns," and his response at the bottom was, "I emailed them to you."
Yeah, that was interesting because so they weren't supposed to make any respond at this and I think that was the one that got the first response from the audience, which they weren't supposed to do, was when he said, "I'll release my taxes." Yeah, when he's, I'll release them when I'm not under audit. Well, how many years is he in audit? He'll be out of he'll be not president anymore. Yeah, right. Yeah, it's bogus. Yeah, it's bogus. Okay. So we filled out the table, and so the first three columns are going to be P, Q, and R, just like before. And then we fill out the table with the logic statement as such. And now I'm going to let you see how much you can fill out yourself. So you can go back and look at your notes. First three columns are the same as the previous example that we did. Yes. Who had a question? Yes. Yeah, it's somewhat redundant in this case. So yeah, R in the third column is the same as R in the fourth column. It's just I like writing out the whole logic expression, not. It's funny all this time though that he's been bombarded by this fact that they have recording of him talking to Howard Stern about being in favor of the Iraq War, and he says no, I wasn't in favor. And last night was the first time I heard about this private conversation with Sean Hannity. I don't know why he hasn't mentioned that for the last 6 months. Seems kind of fishy to me. Yeah, that's interesting because you guys are young enough you don't remember that, but yeah, I remember. Well, we talked about our Sunday school class, and I don't have any recordings of me saying this. I could be lying, but I remember being one of the few people in that group who had serious reservations about going into Iraq, mostly because I didn't think the evidence was sufficient. But the problem is, the thing is, say, she did vote for the war. She was a senator. But again, looking back to that time, you have a president who is presenting evidence saying that they have weapons of mass destruction. You're going into war as a country, and your troops are putting their lives on the line, and you don't want them to think that there's not a united sentiment behind you risking your life. So even though you may have doubts, you don't want to verbalize those because you know your voice by itself is not going to change the outcome, but by saying you're against going in, you're sowing the seeds of doubt. And so you go along with things because of that. And I think that's a lot of people who did vote for going into Iraq probably didn't feel comfortable about them personally, but they wanted everybody, we're behind you, when you go get shot at. It's not like there's the reminiscences of the Vietnam War where you had people protesting against the war and soldiers coming back and then being disrespected, and so they remembered that, and they said, we don't want our soldiers to feel that way anymore. So we're going to unanimously vote to support Bush in doing this war. But so me personally, if I was a senator or a congressman, I probably would have been more likely to publicly say, yes, I'm in favor of it, even though privately I had reservations about it. So the other thing, too, of course, if you said you were against the war, you could appear you were unpatriotic. So, what's that? Yeah, right. Yeah, so you have to do that. And I was, I could, and just personally, when I expressed my concerns about it, I think I got the feeling that people were like, I'm from England originally, so I have to step lightly there. Like, oh, you're not even a real American. You got to do, you're liberal commie. So, so anyway, okay. So let's. So this is. We fill these out. So I'm going to fill these out, and you can see if you can agree. If you agree with what I'm doing here. It's amazing, when I worked at paper mill, most engineers, which is what I'm trained to be, are usually fairly conservative, mostly Republican. There were very few of my colleagues that were as liberal. There was a few of us outliers that we tended to be a little bit more liberal. Okay, so this is copying column R. This is copying column P. This is doing the opposite of what is in this column. And then I apply the AND operator comparing these two columns. So the only time the AND is true is if they're both true. So here's a case where they're both true. Here's a case where they're both true. And that's it. All the rest of them are false because they don't fit my requirement of both being true. And then the last case, I do draw little arrows to remind me of what I'm comparing here, so I don't get confused. So I'm comparing the result of the operation in the parentheses versus the other thing that's on the other side, which is not in parentheses. So then I compare these two values. I look at the operator, which is the OR operator. So again, I look for the cases where they're both false in this case, because that's only one out of the 4 cases. So I go back and forth, and I say, oh, there's 2 falses. I'm going to put a false. Compare these two, those two, those two. There's another one. They're both false. Put that there. And this one's, they're both false. So those are the 3 cases where they're both false. And then the rest of them I can just fill in as true. And so that's the final answer. Does anybody have any questions about how I fill that out now that you see it? How many people got it right? How many people, anybody get it right? Yep, okay, at least some. Okay, this is just to show you the other way you could fill out truth tables, just for your information. You still fill out the first 3 columns, but these things I don't repeat because I've already got it. It's, I'm being redundant. So the first thing that I do is I do the first thing that I don't already have done, which is this negation of Q. So I'll need a column for that. I'll need a column for that. Okay, so I'll need 1, 2, 3, 4, 5, 6. I only need 6 columns to do it the other way. So I'll need, how many? Oh yeah, I needed 9 rows still. 6 columns, so I can do that. There we go. That's 7, 6. There we go. Again, if you like this other way of doing it, some people do, some people don't. I'm only going to show you one way. So you fill out the first 3 columns exactly the same way. In this one, you would do the negation of Q because I need that, and I haven't already done it. Then the next column would be P and not Q. So I do this operation that's in the parentheses. And then the last one, I'm going to do the whole thing, R, or, P, and not Q. And I can't, that's one reason I don't like it, because I can't fit in the whole logic expression. It takes up too much space. So you fill out the first 3 columns exactly the same way that we've done previously. So the one advantage is you use less columns this way. The disadvantage is the last couple of columns take up a lot of space because they're usually fairly long expressions. And the results are all on the right-hand side, which is kind of nice. That's an advantage. So instead of having to look in the middle for the result's in that column here, the result is always in the rightmost column. Okay, so the negation of Q, we take column Q and we switch everything around. Okay, then you do this. So what you have to do is you have to compare this column versus this column. And then you have to use the AND operator. So just like before, we just have to think about, let me put a little red dot here, and I'm going to show that I need to compare these 2 columns using the AND statement. So the AND statement says you have to have them both true for the result to be true. So we compare here with here, here with there, here with there. Okay, there we have 2 trues. Here we have true trues. Put that down. Keep doing it. Okay. No other cases where they're both true, so we fill the rest of it in as falses. Now, the last thing is we're going to do R and this whole thing. So I'm going to use a green for that. So I'm going to put a little green dot. And for the green dot, I'm going to compare this column with that column, because I have R, and the operator I'm using is the OR operator. So I'm going to compare these 2 columns with the rules that apply to OR statements. So I'm going to compare these 2 columns, look for 2 cases where I have two falses, because that's the only case that's false. So I get false, false is false. And going down here, there's a false and a false, so that's false. And there's 2 falses there, so those are the 3 cases. All the other ones have either a true or a false or both of them. And then, so I can make all of them, the rest of them true, because that's how the OR operator works. And if I compare this column versus this column, it's the same, because that's the result. So what do you think? What's that? That looks confusing, yeah. So some people like it that way, I think, just because you do have a case where you can, well, you don't have these cases where you have, a column that is under an operator. The column is under the actual whole statement, and that's why some people might like it. So we talked about equivalent circuits for computers that one might be better than the other. And these are 2 laws that work for logic expressions. So if you have two logic expression, two statements, P and Q, if you have the negation of the quantity P or Q, it's equivalent to the negation of P and the negation of Q. So both of those logic statements will give you the same truth table result, which means they're equivalent to each other. That's why we use 3 lines instead of 2 lines. And likewise, if you take the negation of P and Q, that's equivalent to the negation of P or the negation of Q. And there are more than these are the ones that are introduced in the book, but there are a lot more of them. And if you actually look up computer science De Morgan's laws, you'll see that they exist. We haven't really talked about what equivalent statements are. Equivalent statements are when you get to the end and the truth values at the end of the statements are the same. They all match up exactly as you go down. So we could I put this on the test as something like this. So let's just prove that these use what we've just learned to prove these, at least the first one is true. So what you would do is you would create a truth table. And so I'm going to need, for this side, I'm going to need 1, 2, 3, 4, plus 2. So I'm going to need 6 rows, 6 columns, and 5 rows. So 5 rows, 6 columns. There it is. You don't need to, if you just want to pay attention, not to write this down, it's fine. So you got P, you've got Q, you've got the negation of P or Q. So we fill out the first 2 columns with true, false, and true, true, false, false, and then we have the second column, just true, false, true, false. Okay. The first thing we do is we just copy over what's in the columns for the letters. So we don't have to make any changes because they're exactly the same. And then we apply the OR operator. Well, the OR operator says that it's only false if they're both false. So the only one that's false is this one, and all the others are the true, which this is just the truth table. This part's just the truth table for an OR statement. And then we take the negation of the result of this process inside the parentheses. So the result is this column. So all the trues become falses and all the falses become trues. So instead of true, 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 false, we get false, 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 true. And that's the result of that particular operation. False, 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 true. Now if we do the same thing here, we're going to need 2 columns for the P and Q, and we need 3 columns for the 1 here, 1 there, 1 there. So we only need 5 columns for this part. So it's 5 rows by 5 columns. And if we fill it out, we get P, Q, the negation of P, and the negation of Q. So the first 2 columns are exactly the same as above, because it's the same anytime we have 2 statements. The first thing we do is we either do P or Q like we did here, or we do the negation of the columns. So the P column is true, true, false, false. So the negation of P is false, false, true, true. And the negation of Q is the opposite of true, false, which is false, true, false, true. And then we compare these 2 columns with the OR operator. So the only time the AND operator. I already see I'm having a problem here. What did I do? Oh yeah, I'm okay. So the AND operator, the only time the AND operator is true is if they're both true. So I compare these 2 columns. This is the only one case where they're both true. And all the others have to be false because that's the rule for ANDs. And that's the result of that particular logic statement, which is the second one. And if you compare the two columns, you'll see I have false, 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 true, and I have false, 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 true. And that's how you prove whether two statements are equivalent to each other. If they're the same, then they're equivalent. If they're not the same, then they're not equivalent. So typically I put in a test, I don't always do it where they are equivalent. It's usually a statement on the order of difficulty that you see here, so it's not that big. And you have to show these two columns are the same, therefore they're equivalent. And you could do the same thing for the second one, but we're not going to do it in class. I think I might do it. So there's your homework assignment for this section. And I think I can't remember whether I include the next section in the next test or whether I stop here at section 2. So it's, the next test, what is today, Wednesday? It's probably not going to be next week. It'll probably be the following week, either Monday or Wednesday. I'll let you know more next time. So just to give you a general concept of when the next test will be, which will include the last two sections of Chapter 2 and at least the first two sections of Chapter 3. I have this former, I guess I'm not sure what what I would call my acquaintance with this guy. We played on the basketball team together at high school. And he's a assistant principal now at Patrick Henry High School in Roanoke. He's also African American, and he's my Facebook friend. And he used to be Republican. He said he was Republican until they lost their minds. He posted something the other day, and he said, I had this Trump supporter come up to me and say, I'm going to talk to your boss, and you're going to get fired for all the things you say on Facebook about Trump. And he said something back to me, you don't understand the democracy, do you, or something like that. But it's an interesting perspective on the whole. He lends a very interesting perspective, because you don't have any African Americans who have even thought about being Republicans. But there aren't many, and there's even less probably now than there was before. Oh, the car, yeah. Okay, well, we have 6 minutes left, but I'll let you have 6 minutes off here. What we'll do next time, we'll do another example, another more complicated example, just to reinforce what we've learned so far. And then we'll probably move on to the next section.